Hello everyone. What we're going to be talking about today is inverses and functions. Alright, so one thing we're going to be talking about is what's an inverse relation, what's an inverse function, what is a one-to-one function, and what that means. So what I'd like you to do is draw a small sketch of the graph that you see on the graphing calculator. So what we're going to do is we're going to graph this nice and neat. We go to your graphing calculator, go to Desmos. When you go to Desmos, what you're going to want to do is you're going to want to hit the Y button right there, say equals, and we're going to type in a 3, and then the absolute value, and then X. All right, cool, there it is. Now it says plus 2, so I got to go plus 2. And after you do that, I'd like to go to the table. All right, I'm just going to make a table out of it right there. There's our table. And these are the points that I would like you to write down. So we're going to write this down right here. So if you would, write these points down, and once you do that, I want you to do X. And what we're going to do is we're going to call this the inverse. So let's say this function was f of x. Let's say this was f of x. The inverse would be written like this: f to the power of -1 of x. Now the cool thing about inverses is that basically if you have an ordered pair, we'll call the ordered pair A, comma B. The inverse will always just be B, comma A. Now what does that mean? Well, I'll show you. If that says -2 and 8, this will be an 8 and a -2. If that says -1 and 5, that's going to be 5 and -1. 0 and 2 becomes 2, 0. 1 and 5 becomes 5, 1. And yes, 2 and 8 becomes 8 and 2. So what we're going to do is we're just going to go ahead and kind of plot these, all right, and see what would the inverse look like, all right? So let's go with 8, -2. Now there's 8, -2 would put us right about there if I were to graph it. And if you want to, you can kind of pause the video and get your graph paper out in your graphing journal and graph along with me if you'd like, all right? Then you can press unpause and catch back up. We got 5 and -1. So 5 is right about there. -1 puts us right about here. All right, good. Then 2 and a 0. Well, right there's 2 and a 0. All right, then we got 5 and a 1, so 5 and a +1 right there. And then 8 and 2 right here. Okay, now, what we're going to talk about today is what's called the horizontal line test. All right? Now, if you remember what a function is a special relation. I'll write this down. You know what? I'll go and type it. It'll probably be better. Let's just type it. All right? So what is a function? A function. Put old definition. A special relation where each input, which is like your x value, has one output, which is your y value. So that is the definition of a function. Now, this is a function because each input has one output. All right? You're like, wait a second, what about this input? That doesn't look right because that says -1, 5, and that says 1, 5. Now, -1 goes with one number, and 1 also goes with one number. It just happens to be the same number, but this is a function. It's just not considered to be a one-to-one function. All right? So, a one-to-one function is where each input is only has one y value, and how do I want to say this? You know what? Let's just Google and see if it has a better job of explaining it. Ready? All right. One-to-one function versus just a function. All right? One-to-one function. All right. No two elements in the domain correspond to the same element of the range. So this is not a one-to-one function. That's a parabola. All right. This is cubic. That's a one-to-one function. Parabola aren't. Cubic is. So a one-to-one function is where each one specifically goes to no elements in the y values repeat. So no x values repeat and no y values repeat. A function is where the x values don't repeat. All right, but the y right here, the x values don't repeat, but the y values can. But a one-to-one function, Basically, each element of the domain has one element of the range, and none of them repeat. So how do we know what a one-to-one function is? Whew, a lot of words here. How do we know what a one-to-one function is? Well, we get to do what's called the horizontal line test. And if the horizontal line test, if it touches it more than once, you know that the inverse will not be a function. So this is a function, but it's not a one-to-one function because it hits it, what, more than once. And the inverse right here, you can clearly see that this inverse is not a function because 5 goes with a -1 and 5 goes with a +1. All right, so take a look at our, I think I put some notes down here. Oh, I'll go and zoom in. Okay. All right, so a horizontal line test. All right. A function f has an inverse, f to the power of -1, if and only if the horizontal line intersects the graph of the function at most one point. So this one is a one-to-one function, and its inverse would also be a function. But here, even though this is an absolute value function and it is a function, it hits it twice, so the inverse we know will not be a function. All right? So that's the graph of number 1. All right, let's go ahead and let's take a look at number 2, which is right here. So what I'd like you to do is I'd like you to go ahead and we're going to go ahead and graph number 2 together. All right, so take this right here and we are going to graph it together. I'll go and do it on Desmos. So put f of x equals, I believe it's negative. Then we got a cool little square root. We got x plus 3, which shifts it 3 units to the left. And I believe we got -1, so it's going to go down 1 unit right there. And we're going to make a little table here. We're going to find some ordered pairs that work. So what we're going to do is we're going to take a look at the ordered pairs that actually work in the graph. So I have it in Desmos. All right. So we have -3, -1. Okay. We also have 1 and a -3 right here. So I'm transferring this over. So here, the ones that we're going to be transferring over are, we got -2, -2. We got 1 and -3. We're going to get 6 and -4. So I'm going to go ahead and transfer those back over to this one. So we have, all right, -3, -1, -2, -2. All right. If I do let me go back real quick. If I have a 1, that's at -3. So if we're at 1, we're at -3. So I'll plot it right here. 1, -3. And then I have to put a 6 right here because 6 plus 3 is 9. The square root of 9 is 3. And -3 minus 1 gets me all the way to -4. So I actually have to go all the way to 1, 2, 3, 4, 5, 6, and then I got to go down 4, which puts me right about there. Okay, 1, 2, 3, 4, 5, 6. So I'm kind of running out of room. But you're going to start right here. You're just going to make a graph as best as you can. All right, right through there. Now this is a square root function. And this square root function, so I'll go ahead and put 6 and -4, and you can see from my previous, there's the 6, -4 right there. So this will go on forever, but let's take a look at the domain here. If we look at the domain of this graph, I'm going to put D for domain. The domain is the set of all x values such that x has to be greater than or equal to -3. All right, and then we'll put x is an element of the real number system. In interval notation, we would say hard bracket -3 onto infinity. That's the domain for this. The range starts at -1 and goes down. So basically the range goes from -infinity all the way to -1, and we do a hard bracket. It's in set builder notation, we would say the range is the set of all y values, but we're not going to use the letter y, we're going to use f of x for y. So the set of all y values such that all of my y values are going to be less than or equal to -1. Okay? Now, interestingly enough, that our domain goes from negative 3 to positive infinity, okay? But the inverse of this graph will actually, this negative 1 will come into be important when we find the inverse of this. So on question number 2, it only asks you, if you have the paper here, it only asks you to graph and apply the horizontal line test to determine whether its inverse function exists. Well, you can clearly see that this graph, if I look at it, it only hits it one time, so yes, this inverse would exist. What I want us to do, though, is I actually want you to find this inverse. So if you could write this function down, I want to show you guys how to find the inverse of this function when you're called upon to do so. All right, so here's what I want you to do. You're going to write down the function in your journal, and I'm going to show you how to solve for the inverse of this function. So the first step is just write down the function. The next step is to make f of x your y value. Once you make f of x your y value, then step 1 is to exchange or swap the x and the y value. All right? So see what I did there? I swapped the x and the y value, okay? And now all I'm going to do is I'm going to solve for my new y value. So how would I solve for y? Remember, what I'm doing here is I'm finding the inverse of this function. I'm going to add a 1 to this side. I'm going to add a 1 to this side. I can't combine those. They're not like terms. So I leave it as x plus 1 equals negative square root of y plus 1. Now I need to get rid of this negative. So in order to get rid of this negative sign, you can either multiply or you can divide. By a negative. Well, it's easier just to multiply this both sides by a negative. So what does this become? This becomes negative x minus 1 equals positive square root of y plus 3. Okay. Because this negative cancels out that negative. And then I have to apply the negative to the other side of the equal sign. All right, so far so good. Now what we get to do is we get to unsquare a square root. And how do you unsquare a square root? Now, if you don't know how to unsquare a square root, it's kind of cool. If you look at the calculator, it kind of gives you a hint. If you just look at all calculators, all right? I'm loading my Smart View. Now, look right above something being squared. What do you notice? The square root symbol right there is right above x squared, because that's how you unsquare square root. So we're going to take both sides. We're going to square these guys. So we're going to square both sides of the equal sign. So I'm just going to leave it the way it is. Ready? Equals. And this just becomes y plus 3. All right, cool. Now all I got to do is finish solving for y. Which all I got to do now is just take away a 3. Take away a 3. Huh. So I got y over here, and it's equal to parentheses negative x minus 1 close parentheses squared minus 3. So it's basically, its inverse is a quadratic. But we got to restrict the domain in order for it to truly be an inverse. So I want to show you guys what to do now. So we have this inverse. Oh, it's written like this, by the way, just so you know. My apologies. We got f to the power of negative 1 of x equals negative x minus 1 close parentheses squared minus 3. Now you could do the FOIL method and all that stuff and simplify it, but I'm just going to leave it like that for right now. All right, because I'm going to go over here. I'm going to go to Desmos. All right, and let's see. I'll close that out. So watch this. I'm going to call it g of x instead of f of x equals parentheses negative x minus 1 close parentheses squared, and then what did I have? What did I have to have? Minus 3. Minus 3. And you're like, I think you are sorely mistaken, because these don't look like inverses of each other. But we have to restrict the domain. we can only graph the domain from, now watch this, there's a set bracket right here. We're going to have to say our x values have to be less than or equal to -1. There we go, right there. -1. Because if I plug in a -1 right there, a negative times a negative is a positive, and 1 minus 1 is 0. We got to basically, whenever you're trying to find that domain, set this right here. You got to set that equal to 0. And the only number that can plug in there to set it equal to 0 is a -1. These are inverses of each other. So what is our domain restricted to? Our domain is restricted to all x values less than or equal to -1, also known as from negative infinity to -1. We're going to do a hard bracket because it's equal to right there. So that's our domain for this graph. Now, important information, super important. All inverses reflect across y equals x. That's super important. You need to know that. All inverses reflect across y equals x. Just make inverses look nicer on your paper than on my board here. Here we go. Inverses. You try teaching all day and then do videos after you work all day with no break and see how your handwriting happens, all right? Okay, so all inverses reflect across y equals x. Now, what does that mean? What in the world do you mean? Y equals x. What? Look at that. They're inverses. They reflect. That's beautiful. It's a beautiful reflection. So pretty. Look at it. All right. Now, that's something you just need to know. All inverses reflect across y equals x. Now, check this out. If I said y equaled negative, which I'm just kind of rewriting here, the square root of x plus 3, okay, minus 1, does everybody see that that purple, well, I'll change colors here. There we go. Do you see the purple graph here? See the red graph? See how that means the same thing? But here's how you can see what the inverse looks like in Desmos. It's so cool. You hit x equals, no way, yes way. Why? Are you just exchanging the x and y values? I am. And check this out. This is the actual, listen, this is the actual function. But this is the, like if you just switch in x and y. But look, they match. That's how you can check your work. Isn't that beautiful? I know, it's pretty awesome. Desmos, thank you so much for making my job easier just teaching. All right, now this is not your final answer because it's in the form of x equals, and we got to get into the form of y equals with a restricted domain, but at least you can see what it looks like. Beautiful. All right, we're going to go and clear everything out. Start over. Okay, boom. All right, let's take a look at this next one. All right, now I'm not going to go through and solve the inverse on this one. All right, all I'm going to do is type it in right here, and then type it in where you switch out the x's and the y's and put y equals x. So you can see that these are, both of them are functions, okay? So right here, this was your original function, all right? And it is a one-to-one function, therefore it will have an inverse that is also a one-to-one function, okay? Now the last one we're going to do is very, very, very common. It's a linear function. You definitely need to know how to solve for the inverse of a linear function. So if you would, what we're going to do is we're going to go ahead and graph this one. It's very, very easy to graph, so we're going to go ahead and just graph it by hand. It won't take that long. We're going to say f of x equals, except instead of x over 5, I want you to put 1/5 of x plus 2. All right, and here's your slope. It's 1 over 5. Here's your y-intercept 2. So we'll just kind of go and graph it. There we go. Go up 1 over 1, 2, 3, 4, 5. There we go. Go down 1 over 1, 2, 3, 4, 5. There you go. And this is your graph. You can clearly see. Come on, you can do this. There we go. Let's make a nice straight line. So there's our linear function. And it does pass the horizontal line. It's only going to touch it once. So how would we find the inverse of this? Well, first thing we're going to do, so we're going to make that a y. Okay. Now swap the x and the y now. Ready? Swap the x and the y. So x equals 1/5 of y plus 2. It's horrible. Do a better job. There we go. Now, once we swap it, now we got to solve for our new y. So what do we do? Well, there's our equal sign. You take away 2 from this side, take away 2 from this side. If you want to, pause the video, see if you can solve for y all by yourself, then unpause it and see if you got it right. Or don't pause it and just watch me go through it if you want. All right, let's see what we got here. X minus 2. We got x minus 2. Can't combine them. Not like terms. 1/5 of y. Now, if you have a 1/5, multiply it to a y. It's so awesome. All you got to do is on this side, multiply it by 5. And then here's where students make a mistake. They forget to multiply the whole enchilada by a 5. So you got to distribute that 5 to both terms. So this 5 cancels out this 5. And you're left with y equals 5 times 2. Sorry, 5 times 2. 5 times x is 5x. And 5 times negative 2 is negative 10. And there we go. There's our inverse. So I'm going to put the inverse of a. The inverse of our function is going to equal 5 times x minus 10. Bam. There we go. Now, what will that one look like? Whew. Okay, so unfortunately, we got like our y-intercept is like way down here. Okay, but we do know that this is going to reflect across y equals x. So if you know that it's going to reflect across y equals x, then if you want to, you can draw y equals x. Take a look. Right, I'm doing the best I can here. Come on, there we go. Take a look at this ordered pair. If you know that ordered pair is at 0, 2, then you know you got yourself a 2, 0. And then if you want to apply a slope of 5, then just go down 5 units and over 1, and bam. Up 5 over 1, down 5. There we go. I just found a beautiful way to graph. Now, how did I do that? Let me go over one more time how I did that. That's awesome. It looks pretty good. So I saw I have a 0, 2. So I know the inverse has to be where? At 2 and a 0. Then I just applied the slope of 5 and did my 5-to-1 ratio so I could graph it on the grid right there. There's the up 5 and over 1. Now you can still use Desmos on this if you want. All right, so we'll go over here to Desmos. Let's take out that. Let's go over here and we'll type in exactly as it appears. X over 5, and I said plus 2. Okay. Now what did I say you could do? You could say x equals y divided by 5 plus 2. And I'll change the color to orange just because, we had ours in orange. Because, it's cool. And then, what did I say our inverse was? I said it was y equals 5x minus 10. And what do you notice about the blue and the orange? Not only do they really good colors, are very good complementary colors and go well with each other if you're wearing them, they also right now happen to be, this lets you know that I solved for the inverse correctly. Remember I said about our ordered pairs? Check this out. If that says 0, 2, all right, it says 0, 2. Look what this one says. This one says, wait for it, 2 and a 0. There it is. It's awesome. All right, so those are inverses. All right, so the last one we're going to do today, and we're going to call it a day. And you're going to be like, thank goodness, because I am tired. By the way, we're going to do number 6 tomorrow. But we're going to go ahead and just solve for number 5 today. It says, determine whether f has an inverse function. If it does, find the inverse function and state any restrictions on its domain. So we're going to do number 6 tomorrow, okay? But today, we're going to go ahead and finish up with number 5. So let's take a look at number 5, all right? Close it out. Close it out, close it out, go ahead and do f of x, take a look at it, cubic root. Now here's how you do a cubic root, all right, in Desmos. You go to functions, you go to miscellaneous, and then you go to that cool little nth, that's your index. You type in a 3. Then over here you put x plus 3, and boom, you're done right there. That's a wicked looking function. Ooh, look at there, that's called a point of inflection, in case you didn't know that. That's a point of inflection. All right, it's kind of cool because it just changes, it's still increasing, but it just changes direction without it being a point where it changes from like a maximum to a minimum. It's kind of cool, point of inflection. Oh, unfortunately it says -1, my apologies. There we go, so now the point of inflection is right there. All right, so here we go. Whew. First step, Let's exchange the x and the y. So x equals the cubic root of y minus. Look at that. So that's what our inverse is going to look like. Okay, that's what our inverse is going to look like. And there's another point of inflection. It's kind of cool. Kind of reminds you of like a hourglass kind of look. So how do we solve for this inverse? So let me show you. This will be the last thing that you do. So you're just taking notes, trying to get used to solving inverses. So when you have a quizzes or Khan Academy, and I say, hey, solve for this inverse, you'll have some good notes on how to solve for an inverse. All right, so here we go. So we have x equals this. So what are we going to do? We are now going to solve for y. So if x equals the cubic root of y minus 1, how do we get rid of this pesky cubic root? You're probably saying to yourself, well, dude, just cube it. Okay, I'll cube it. I'll cube this side and I'll cube this side. Stop yelling at me, okay? So we're going to cube both sides. You're left with x cubed equals y minus 1. O-M-G. Which means, oh my goodness, I'm not taking the Lord's name in vain or anything like that. Oh my goodness. So what do we got to do to solve? Just add 1 to this side, add 1 to this side, and we're done. Is that it? That's it. Y equals x cubed plus 1. So we'd say the inverse of our function is x cubed plus 1. And that is our final answer. That is the inverse. Let's see if we got it right. Ready? Ready? X to the power of 3 plus 1. Yes! And it's awesome because you can see how it reflects perfectly across y equals x. So, you're like, I am not going to remember how to solve for an inverse. Well, if you don't know how to solve for an inverse, instructions. Instructions, here we go. Step 1. Determine whether the function has an inverse by checking to see if it's a 1-to-1 using the horizontal line test. Then, in the equation of f of x, replace f of x with y, and then interchange x and y. Then solve for y, and replace y with f to the power of negative 1. Then state any restrictions on the domain of the inverse. All right? So, wait a second. We didn't do that last part, but it's okay. It's okay. We didn't do the last part because there are no restrictions. All right? This is a cubic function. There is no restrictions on the domain. Okay? No restrictions whatsoever. So we are good to go. It's all real numbers for the domain. You'll have a wonderful day. Hope this was helpful. I had fun. Hopefully you had a little bit of fun. Not like Disneyland fun, but maybe Knott's Berry Farm fun because it's not quite as fun as Disneyland.